Let's look and see what happens when we differentiate sin x and cos x. So we'll start off with our sin x function. So that's our sin x function here. Now we can differentiate it here, so if I click on this it will give you the differentiated function. So this is the differentiated function. So you can see here that whenever we differentiate this sin x, which is in blue, we get this function here, which is in green. But this function in green is nothing other than cos x. So I'll put in cos x just to prove that to you. I'll put in cos x. You can see here that it just sits right on top of that function. So when we differentiate sin x, we get cos x. Now let's have a look and see how we can work that out intuitively. If we start off with our sin x function, we can see here that the differentiated function just gives us the rate of change of the original function at each point. So we can see that the function sin x is changing at its greatest rate at this point here. And again, it's a positive rate of change, so we've got a positive value there, which represents the rate of change at that point. But then you can see the rate of change, it slows down, and it slows down, eventually it gets to this point here. The rate of change is 0. So the rate of change has slowed down, it's got smaller, it's got to the point 0. But then the rate of change starts increasing again, but it starts increasing in a negative fashion. So the rate of change is from left to right, it's dropping down the way, so it's a negative gradient. So it means that we're going to start getting negative values here. And we've got the maximum rate of change at this point here, but it's a maximum negative rate of change, so here's the maximum point here. And then we can see that the rate of change starts to decrease again, and it decreases until eventually it gets to a value of 0. And this is the rate of change. The height here tells you the rate of change, and you can see that height is decreased until it gets to a value of 0. So it starts mapping out this cosine function. So let's go ahead and we'll do the same for the cosine function. We'll find out what happens when we differentiate it. So we'll take the sine function off. Now we're going to look at the cosine. So this is our cosine function here, and whenever we differentiate it, we're going to get this black function. Now you can see that this black function is actually the minus sine x function, so it's like the sine x, but it's got a minus sign in front, and we know from manipulating functions that's equivalent to reflecting it on the x-axis, so it gets flipped over. So just to show you this here, this is the minus sine function, so if I click on that, you'll see it just sitting over the top of that function there, so we know it's a minus sine function. And again, you can work that out just by looking at it. So if we started off with a cosine function, you can see that the rate of change at that point is 0. So it means that the derivative, the differentiated function, has got a value of 0 at that point. And you can see that the rate of change starts increasing, but it's increasing in a negative fashion. So its maximum rate of change is negative at this point here. So that becomes a maximum value at this point here, which is a negative value. And again, the rate of change starts to decrease until eventually it goes to 0 again. And you can see this is the height here, is the decrease in the rate of change, and it goes to 0. So whenever we differentiate the cosine function, we get the minus sine. So let's go and we'll write that out mathematically. So this is us just written down what we've learned from the graphical calculator. When we differentiate sin x, we get cos x, and you can see this here. This is our original function f of x, which is sin x, and when we differentiate it, we get the cos x function. And whenever we differentiate cos x, we get minus sin x. So the original function here, f of x, is our cos x function, and when we differentiate it, we get the minus sin x. So we could take these and we could add them on to a table that tells us the differentiations of particular functions. So for example, we've already worked out in a previous video that when we differentiate ax to the n, we get nax to the n minus 1. So that's one part for our table. The second one could be when we differentiate sin x, we get cos x. We differentiate cos x, we get minus sin x. So those are three different lines that we could add to a table of differentiations. So thank you for listening, I'll get you in the next video. Goodbye.